so let's talk behavior of graphs. So f of x equals x. I'm going to use black for all the parent functions. So we just talked about this. There's no fanciness to this. This is the same as saying the function of x equals x. It means if you put x in, what am I going to get out? Input is x, output is y. This is just like saying y equals x. You just need to get used to it. When you see f of x, or the function of x, that's just your y value, okay? But it's not going away, so I'm not going to write it that way. Okay, you just need to get yourself used to that. So y equals x looks like this, right? Straight through the middle of the graph. What do we call this type of function again? Did I hear it? It's an identity function, right? Why is it an identity function? Because it's equal. Because if I put in 1, I get 1 out. If I put in 2, I get 2 out. What I put in is what I get out. Okay, identity. F of x equals x squared. What's that one look like? That one's a parabola, centered at the origin. What would f of x equal to 0 look like? So instead of saying f of x, I could say y equals 0, and y equals 0 is a horizontal line. Good. And we already talked about this one. F of x equals the absolute value of x. Looks like a V, right? Looks like a V. Oops. Let me change that. So from my center out. I don't like that other one. That works better. Okay, now let's talk about if I add anything to the equation, how that affects the equation. So f of x equals x plus 2. What color do we want to make this one? Let's make it green. So what would, now this is a rough sketch, okay? All these are going to be sketches. What would f of x equal to x plus 2 look like? Let me make this line green. So I'm starting here. Where would I go? Up 2. Is that 2? I would shift up 2. Same line. Slope is still the same, right? Only it's shifted up 2. What about 4x minus 1? What color do you want to make that one? Red. Got it. So let's make that one red. Take my parent graph, copy it, paste it, make it red. What are we going to do with it? It's at the center, at the origin. What's going to happen to it? Somebody raise your hand and tell me. Okay. Okay, so it's going to shift down 1. Is that it? It's going to be tilted. We'd say, is it going to be steeper or less steep? It's going to be steeper. Why? Not because it's positive. Because it's going up at a rate 4 times faster. Isn't that what 4 times s means? Faster by 4. The rate is multiplied by 4. If I multiply rate by 4, it means you picked it up a notch, right? If you're running a race and you run 4 times faster, you're going to go faster. All right, so I'm going to make it more steep. So we'll do something like that. I'm going to be exaggerated. How about that? You think it's more than that? Go down and more steep. More like that? I agree. Needs to be down 1. Okay, what about this one? 1/2 of x minus 6. What color are we going to make that one? I don't have purple.
Orange.
Let's do orange. Alright, so I'm going to go ahead and grab my parent graph again. Hopefully that's the one I got. I did, and let's make it orange. Alright, so what's happening with this graph? 1/2 of x minus 6. It's going to shift down 6. Then what? It's going to be how much less steep? Half. It'll be half as steep. So if I say you're running a race and you went half the speed, it would drop, right? So this is going to be dropped. So taking a fraction of the slope would make it drop or less steep, and increasing your slope would make it more steep. All right, let's look at f of x equals x squared. What would... Let's just go ahead. I'm going to do this now. This is green, this is green, this is green. This is red, this is red, this is red. Orange, orange, orange. Uh-oh. I'm trying to group this. Okay. All right. Undo. I don't want these graphs to move on me. Looks like I don't have a choice. Why is it doing that to me? I don't know. There, that's better. Okay, so there's our parent graph. All that work and it's not going to work. Alright, I'm just going to change the color. We should have gone with pink instead of orange. Okay, let's start with our green. X squared plus 2. What's going to happen to it? It's going to shift up 2, right? What about 4x squared minus 1? Drop 1, and then what happens to it? 4x squared? It's going to shoot up faster, so it's going to be skinnier, right? Just think of a track star. Somebody who's going really, really fast, it's going to be really steep and really skinny, right? I hate to put it in those terms, but it works, right? So it's going to be shifted down 1, and it's going to be steeper. And what about half of x squared minus 6? Down 6, and what happens to the slope of it? It's going to be wider. It's going to be fatter, right? It's all the way down 6, and it's going to be wide. Make sense? Okay, what about this one? The green one, where's that going to be? Up 2, this one's pretty easy, right? And the red one? Down 1, and the orange one? Down 6, it's not perfect. Absolute value. What's the absolute value of x add 2? Shift it up 2. Here's it again. How many of you have already seen this explained to you like this before? Okay, so I'm not repeating myself too much. What about 4x minus 1? Absolute value of 4x minus 1. What's the first thing you can say about this graph? It's going to start at negative 1. What's the 4 going to do to it? Make it steeper. So what about half of x minus 6? Starts at negative 6. And it's going to be wider. All right, those are the basics of behavior graphs. We're going to take that, those building blocks, and we're going to go a little bit more intense. I would love it. One. All right, so I have these in your presentation for you so that you can have it as a reminder. This is a constant function, identity function, absolute function. I've included this graph here, and this table here for you as well. You can see that you always start at the middle or at the origin, and if you work your way out, you see if I look in the positive direction I get 1, and if I look in the negative direction I get 1, that's where it's symmetrical. Positive direction I get 1, negative direction I get 1. Positive direction 2, I get positive 2. Negative direction of 2, I still get positive 2. Make sense? Okay. So actually, if you're doing an absolute value function, as soon as you do kind of one side, you know that the other side's mirrored, right? And that's definitely something that you should have gotten from Algebra 1 and Parabola, okay? I don't get a lot of head nodding in this class. Yes. Okay, good. All right. Pencils down. Let me graph this. Okay. Absolute value means what? Distance. When I find the distance between two things, aren't I finding the difference between them? So if I were to say, I want to find the distance between 2 and 6, how could I find the distance between 2 and 6 rather than just counting? I could subtract. I'm finding the difference between them. The difference between 2 and 6 is 6 minus 2 or 2 minus 6. Both of them will give you distance. You can say 2 minus 6, right? Because when you get negative 4, distance is always absolute, right? Absolute value. So that would actually be 4. No matter which way you look at it, 6 minus 2 or 2 minus 6, when you're talking distance, it's positive. All right, that being said, this is really this. Correct? The distance between x and negative 1. Right? Just like we did in the last chapter. Okay. So, this time, instead of it, we've done this one, the absolute value of x plus 1. How would that look if it was a graph? If we graph that, what behavior would that graph have? We just did this. How would it shift? It would shift up 1. But this time, the number is inside of the absolute value. So instead of shifting vertically, what do you think it's going to shift? It's going to shift horizontally. All right, it's going to shift on the positive and the negative on the x-axis. So we say that the distance between x and negative 1. So we're going to go in the negative direction on this one. Okay, let's do this. Let's do 0. If I put 0 in here, what do I get? I think I was looking at this one, and that's why I went this way. 0 plus 1 is 1. So we have 0, 1. No, it still will be. Okay, now what would you like to put in? 1. What's the absolute value of 1 plus 1? 2. So if I go over 1, I'm going to go up 2. So what if I go in the opposite direction? Negative 1, what happens? What's negative 1 plus 1? 0. So if I go negative 1, it's going to be 0. Isn't that what I said in the very beginning? It's going to shift over this way. So if it's positive 1, it's going to shift in the negative direction, because this is really what it looks like. X minus minus 1. All right, so what do you think I'm going to get when I put in negative 2? Nope, it's going to go, right? Because if this is the vertex of it, isn't it? And if I put in negative 3, shouldn't it mirror? There's like an axis of symmetry right here, if you can see it. At negative 1, you've got an axis of symmetry. So it's going to look like this. Let's finish this one. So if I put in negative 2 plus 1, I'm going to get negative 1, but the absolute value of negative 1 is 1. And if I go in this direction and I put in 2, I'm going to get 3. Okay, so where is our center really? You see it starts right there? That's where it starts mirroring. Make sense? So what would negative 3 be? You should be able to look at this and tell me. Right? Shouldn't say 0, 1, 2, 0, 1, 2. What's the next one going to be? See what I mean? Like that's where it's starting. It's not at 0, 0. It's at negative 1, 0. That's when you're going to start seeing that symmetry happening. Okay? Let's talk about domain and range before you copy this down. This is going to be super, super, super important. Okay, let's use the same color for all of them. Let's use red. I'm going to use red to say this is my line, my domain line, or I don't even know. Okay, so I'm going to go along the x-axis. We're going to jog along the x-axis, and you're going to tell me when is the graph intercepting my, I don't know, what, for lack of a better word, what could we use? It's going to be my shade of, my domain shade. So as I'm running along, is the graph intersecting my domain shade? Does it keep intersecting my domain shade? Keep intersecting? Yes? As we go along the x, what's happening? Well, it would be if I would keep going, right? Isn't it always going to intercept my domain shade all the way across? So what would we say about this domain? All real numbers. All right, let's shift it to a range shade. That's measuring, that's going up and along the y-axis. Do you see why it's horizontal now? Because it's going up and down the y? Is it intercepting my graph? No, 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 no. When does it start? When is it going to start intercepting it? Right there. Not at negative 1. Where is it on the y? At 0. It's at the y, it's at 0 on the y-axis, right? And it's going to continue intercepting it all the way to infinity. Correct? So my domain would be greater than or equal to 0. I should have put my y such that in there. Let's do this. I think I'll start doing this. Say y is greater than or equal to 0. What are we talking about? Y. Put on the curtain. Okay? All right, go ahead and copy that down. All right, so I'm going to do this one. Let's talk about what this would look like. Let's talk about the behavior of it. What's going to happen to it? It's going to shift, what? Vertically 2. And what's going to happen inside of it? Careful here. Absolute value is distance or difference, right? So isn't this really saying this? So which way is it going to shift? Left or right? You must ignore this. Ignore it. That's part of, it's the distance between these two, right? So if I'm ignoring that negative sign, which way is it going to shift? To the right. You see what I mean? Okay. So it's going to shift to the right, over 2, and it's going to shift up 2. So it's going to start right there. Is the slope going to be any different of these lines? Is anything affecting the slope? Who's in charge of slope? X or Y? In slope-intercept form, who's in charge of the slope? Where does the slope go? In front of X. Slope is connected to X, right? So is there anything affecting X right now? No. If I were to actually graph this, I can, without even plotting any points, I can already tell it's going to be over 1, up 1, over 1, up 1. Oh, my slope's 1 over 1. I don't have a slope. It's 1. Correct? If you just go based on behavior of graphs, I've already graphed it without doing any work, just by thinking about it. All right? So we'll do the dirty work. So where am I going to start? What's my middle going to be? What's my middle going to be? My vertex. It's going to be 2, 2. Who believes me? You can see it right there, right? So if I put in 2 minus 2 plus 2, aren't I going to get, this is going to be 0 plus 2. I'm going to get 2. 2, 2. So where should we go now? Going in the negative direction, I would go to 1. Going in the positive direction, I'd go 3. Let's see what happens when I do that. Let's put in 3 first. 3 minus 2 plus 2. What's that going to be? 3. I'm guessing this is going to be 3 also. 1 minus 2 plus 2. Is that going to be 3? Absolute value of 1 minus 2 is negative 1. The absolute value of negative 1 is 1. 1 plus 2 is 3. Going in this direction, 4. What would this one be? 2, 1, 0. If I put, what do you think this is going to be? 4. What do you think this is going to be? 4. It's symmetrical, right? So my advice to you, now, usually you're taught in old traditional ways is you start at 0, 0, right? You start at 0 and you work your way out. I would much rather you think about where the vertex is, how has the graph shifted, and start there. Isn't this a lot less work? If you already know, you can predict what this is going to do. So if I put in 0 minus 2 plus 2, I think we all agree that's 4. And 4 minus 2 plus 2, we'd all agree that's 4. Right? Okay, let's go, what do we call it again? Our shade of domain. Here's our domain shade. Is the graph intersecting the shade? It is technically, because look, this line could keep going, right? So when is it going to stop intersecting the shade of domain? Never. So what's our domain? All real numbers. Let's switch it over to a range shade. When's it going to start intersecting my range shade? At 2. So y has to be greater than or equal to 2. We're talking about y, put the curtains on. How you guys doing? Not too bad? Alright, let's try this one together. Do you guys want to try it first? Let's talk about what it's going to look like first. What's this going to look like? What's the behavior of this graph going to be? Shifted vertically down 1, right? And where is it going to begin? It's going to begin at, is it going to go in the positive direction or in the negative direction? Positive direction. Forget about that. It's all about this. But if this was a positive sign, which direction would it go in? The negative direction, because that would be really x minus negative 3, right? That's what made it positive. Absolute value always has that negative sign. All right. So my vertex should be at what? We went over 3 and down 1, so it should be 1, 2, 3, negative 1. That should be my vertex. So it will be my first number that I would substitute in for x, 3. And I'd work my way from that. And what should I get? Negative 1. If I substitute in 3, I should get negative 1 based on what we just talked about, the behavior of the graph. You should get something that looks like this. What's the slope of this absolute value graph? What's the slope of it? What's in front of the x, guys? 1. What's the slope? 1. 1 over 1. Over 1, up 1. Over 1, up 1. Over 1, up 1. It's not perfect up on there. I've got it. Oh, it's pretty good, huh? It's pretty close. 1. Okay, so you should have something like this filled out. What's my domain? All real numbers. When does it intersect for y? Y has to be greater than or equal to negative 1. Let's talk about g of x. Just a different function. That's why they named it something different. Since they named it something different, I'm going to use a different color. Alright, so this function, what's happening with this function? There's a half in front of it. Let's see what happens. Alright, so where do you think my vertex is going to start? We're going to go down, right? 1, and then what? In the positive or the negative direction? Positive. So over 3, so in the same spot? Let's see. If that's really our vertex, then I should get the same thing. So if I put in 3, what happens? I get 1/2. Then 3 minus 3 equals 0. 0 times a half. The half has nothing to do with this one, right? The half doesn't even affect it because the half is multiplied by 0. So it is, in fact, right there. That's my vertex. So predict. Is it going to go out like this? Is it going to have the same slope? How is it going to change? By 1/2. So would you graph that without doing any of this? Would you graph that over 1 up 2 or over 2 up 1? Think about that. Would you go over 1 up 2 and then over this way up 2? Or would you go over 2 up 1? Over 2 up 1? Over 2 up 1. Why? Because what? Right here? No. It's supposed to be a 1/2. Why? Wait, say it again. It's going to be like this. Why? Why would I go over 2 up 1 and not over 1 up 2? Isn't this say 1 over 2? The steepness, right? It's the steepness. It's half as steep. It's not steeper, it's half as steep. More importantly, when you talk about slope, slope is not over and then up. What's slope? Up and over. So it is going up 1 over 2, or over 2 up 1, if you really want to say it that way. Correct? So if I have to go over 2 to go up 1, what would you say you would put for the next value? I wouldn't put in 4, I'd put in... I'm pushing you here. You guys have never had to think like this, right? So instead of putting 4 here, inputting 4, what would make it a nice, pretty number? Not -3. What? No. 5. If I went over 2, instead of going over 1, I would go over 2 because it's going to be a wide graph. Didn't I go over 2 up 1? No, I'm sorry. We'll change it. If I go over 2, how much is it going to increase? 0. The first one was 0. Oh, no. The first one is -1. Thank you. So so now it's going to be 0. What would be the next one? 7. And what would that be? 1. See, I'm making you think rather than just do math. You guys can all plug in numbers. I'm trying to make you think about what the graph is going to do. I can plug in 7. You need to see this. I love it. So 7 minus 3 would be 4. Half of 4 would be 2. And 2 minus 1 would be 1. Beautiful? No? Interesting?
No.
So if I went in this direction, what would you go to get a nice even number?
1.
1. If I put in 1, what am I going to get?
0.
What would be the next number you put in? -1. What would you get? 1. Without even doing the math, I can see the symmetry in it. Right? If you're not comfortable doing this, then you can do the good old-fashioned math, right? But you only have to do a couple to be able to see where it's going. And the key is, you didn't have to, did I have to do any math to sketch that? I thought about it. I made sense of the problem. Okay, what's the domain? All real numbers. What's the range? Greater than or equal to what? -1. How much time do I have? 2 minutes?
2.
All right, what did you learn today? Behavior of graphs, yeah? What's the difference between a constant and an absolute function? What's constant look like? Going constantly, either horizontally, right? Right? All right. How would you explain why a vertical line isn't constant? Ooh. We'll come back to that one. I want you guys to get this. The graph f of x equals x minus 2 plus 1 would shift what? Shift. Right?
What? Oh, yeah.
Right what?
Right, 2.
You want to start with the outside first?
That's what it's on.
So up 1 and
Right 1. Right 2.
right 2. Because? Why? All right. As long as you've got up 1, right 2. Good job, guys.
I'm not going to do the